Hi and Assalamualaikum. My name is Isiman Hazi. My matrix number is 3202037092 and my lecturer name is IR Rabita binti Handan. Today I'm going to present about one of the civil engineering material that we called as bitumen. First, introduction. Asphalt, also known as bitumen, is a sticky, black, highly viscous liquid or semi-liquid form of a petroleum. It may be found in natural deposits or may be refined product and is classed as a pitch. Before the 20th century, the term asphaltum was also used. The word is derived from the ancient Greek asphaltos. The largest natural deposit of asphalt in the world, estimated to contain 10 million tons, is the Pitch Lake located in La Brea in southwest Trinidad. Atlas Islands, located on the northeastern coast of Venezuela, within the Siparia Regional Corporation. The primary use, 70% of asphalt, is in road construction, where it is used as the glue or binder mixed with aggregate particles to create asphalt concrete. Its other main uses are for bituminous waterproofing products, including production of roofing felt and for sealing flat roofs. In material sciences and engineering, the terms asphalt and bitumen are often used interchangeably to mean both natural and manufactured form of the substance, although there is regional variations as to which term is most common. Worldwide, geologists tend to favor the terms bitumen for the natural occurring material. For the manufactured material, which is a refined residue from the distillation process of selected crude oils, bitumen is the prevalent terms in much of the world. However, in American English, asphalt is more commonly used. To help avoid confusion, the phrases liquid asphalt, asphalt binder, or asphalt cement are used in the US. Colloquially, various forms of asphalt are sometimes referred to as tar. Is in the name of La Brea tar pits. Although tar is a different material, naturally occurring asphalt is sometimes specified by the terms crude oil, bitumen. Its viscosity is similar to that of cold molasses, while the material obtained from the fractional distillation of crude oil boiling at 525 degrees is sometimes referred to as refined bitumen. Etymology. The word asphalt is derived from the late Middle English, in turn from French asphalte, based on late Latin asphalton, asphaltum, which is the Latinization of the Greek asphaltos or asphalton, a word meaning asphalt, bitumen, pitch, which perhaps derives from alpha, not without the alpha privative and espalion, to curse, to fall, baffle in passive, err in passive, be bulked of. The first use of asphalt by the ancients was in the nature of cement, from securing or joining various objects, and it thus seems likely that the name itself was expressive of this application. Especially, Herodotus mentioned that bitumen was brought to Babylon to build its gigantic fortification wall. From the Greek, the words passed into late Latin and thence into French asphalte and English asphaltum and asphalt. In French, the term asphalte is used to naturally occurring asphalt-soaked limestone deposits, and for specialized manufactured product with fewer voids, a greater bitumen contain the asphaltic concrete. used to pave a road. The word bitumen is from Latin and passed via French into English. Modern terminology. In British English, bitumen is used instead of asphalt. The word asphalt is instead used to refer to asphalt concrete, and mixture of a concrete aggregate and asphalt itself, also called tarmac in common parlance. Bitumen mixed with clay was usually called asphaltum, but the term is less commonly used today. In Australian English, the word asphalt is used to describe a mix of construction aggregate. Bitumen refers to the liquid derived from the heavy residues from crude oil distillation. In American English, asphalt is equivalent to British bitumen. However, asphalt is also commonly used as a shortened form of asphalt concrete, therefore equivalent to the British asphalt or tarmac. In Canadian English, the word bitumen is used to refer to the vast Canadian deposit of extremely heavy crude oil, while asphalt is used for the oil refinery product. Diluted bitumen, diluted with naphtha to make it flow in pipelines, is known as dilbit in the Canadian petroleum industry, while bitumen upgraded to synthetic crude oil is known as syncrude, and syncrude blended with bitumen is called synbit. Bitumen is still the preferred geological term for naturally occurring deposits of the soil or semi-solid form of petroleum. Bituminous rock is formed of sandstone impregnated with bitumen. The oil sands of Alberta, Canada are a similar material. Second one is a composition. Normal composition. The components of asphalt include four main classes of compounds. The first one is naphthalene aromatics naphthalene, consisting of partially hydrogenated polycyclic aromatic compounds. Second one is polar aromatics, consisting of high molecular weight phenols or carboxylic acids produced by partial oxidation of material. Third one is saturated hydrocarbon. The percentage of saturated compounds in asphalt correlates with its softening point. The fourth one or the last one is asphaltens, consisting of high molecular weight phenols or heterocyclic compounds. The naphthalene aromatic and polar aromatic are typically the majority components. Most natural bitumen also contain organosulfur compounds, resulting in an overall sulfur content of up to 4%. Nickel and vanadium are found at 10 greater than 10 parts per million. As is typical of some petroleum, the substance is soluble in carbon disulfide. It is commonly modeled as a colloid with asphaltenes as the dispersed phase and maltines as the continuous phase. It is almost impossible to separate and identify all the different molecules of asphalt because the number of molecules with different chemical structure is extremely large. Asphalt may be confused with coal tar, which is visually similar black thermoplastic material produced by the destructive distillation of coal. During the early and mid-20th century, when town gas was produced, coal tar was really available byproduct, and extensively used as the binder for road aggregates. The addition of coal tar to macadam road led to the word tarmac, which is now used in common parlance to refer to road-making materials. However, since the 1970s, when natural gas succeeded town gas, asphalt has completely overtaken the use of coal tar in this application. Other examples of this confusion include the La Brea tar pits and the Canadian oil sands, both of which actually contain natural bitumen rather than tar. Pitch is another term sometimes informally used as time to refer to asphalt, as in Pitch Lake. Additives, mixture, and contaminants. For economic and other reasons, asphalt is sometimes sold combined with other materials, often without being labeled as not anything other than simply asphalt. Of particular, it is the use of the refined engine oil bottom REOB or REOBS. The residue of recycled automotive engine oil collected from the bottoms of refining vacuum distillation tower. In the manufacture of asphalt, REOB contains various elements and compounds found in recycled engine oil, additives to the original oil, and material accumulating from its circulation in the engine, typically iron and copper. Some research has indicated an correlation between this adulteration of asphalt and poorer performing pavement. Third one is occurrence. The majority of asphalt used commercially is obtained from petroleum. Nonetheless, large amounts of asphalt occur in concreted, concentrated from concentrated form in nature. Naturally occurring deposits of bitumen are formed from the remains of ancient microscopic algae, which is diatoms, and other ones living things. These natural deposits of bitumen have been formed during the Carboniferous period, when giant swamp forests dominated many parts of the earth. They were deposited in the mud on the bottom of the ocean or lake where the organisms lived. Under the heat above 50 degrees and pressure of a burial deep in the earth, the remains were transformed into materials such as bitumen, kerogen, or petroleum. Natural deposits of bitumen include lakes such as Pitch Lake in Trinidad and Tobago, and Lake Bermudas in Venezuela. Natural seeps occur in the La Brea tar pits and the McKittrick tar pits in California, as well as in the Dead Sea. Bitumen also occur in unconsolidated sandstone known as oil sands in Alberta, Canada, and the similar tar sands in Utah, US. The Canadian province of Alberta has most of the world's reserves in three huge deposits covering 100,042 square kilometer, equivalent to 55,000 square mile, in area larger than England or New York State. The world's largest deposit of natural bitumen, known as the Athabasca oil sands is located in the McMurray Formation of northern Alberta. This formation is from the early Cretaceous and is composed of numerous lances of oil-bearing sand with up to 20% oil. Isotopic studies show the oil deposit to be about 110 million years old. Two smaller but still very large formations occur in the Peach River oil sands and the Cold Lake oil sands to the west and southeast of the Athabasca oil sands, respectively. respectively. Of the Alberta deposits, also parts of Athabasca oil sands are shallow enough to be suitable for surface mining. The other 80% has to be produced by oil well using unchanged oil recovery techniques like steam-assisted gravity drainage. Much smaller heavy oil or bitumen deposits also occur in the Uinta Basin in Utah, US. The tar sand triangular deposits, for example, is roughly 60% bitumen. Bitumen may occur in hydrothermal veins. An example of this is within the Uinta Basin of Utah in the US, where there is a swarm of literally of vertically extensive veins composed of a solid hydrocarbon therm gilsonite. These veins formed by the polymerization of solidification of hydrocarbon that were mobilized from the deeper oil shales of the Green River Formation during burial and diagenesis. Bitumen is similar to the organic matter in carbonaceous meteorites. The fourth one is history. First, ancient times, the use of natural bitumen for waterproofing and as an adhesive dates at least to the 5th millennium BC, with a group storage basket discovered in Mehgar of the Indus Valley civilization lined with it. By the 3rd millennium BC, refined rock asphalt was in use in the region and was used to waterproof the Great Bath in Mohenjo-daro. In the ancient Middle East, the Sumerians used natural bitumen deposits for mortar between brick and stones to cement parts of a carving such as eyes into place, for ship caulking and for waterproofing. The great historian Herodotus said hot bitumen was used as mortar in walls of Babylon. The 1 kilometer, which is equivalent to 0.62 mile long Euphrates tunnel beneath the river Euphrates at Babylon in the time of Queen Semiramis, between maybe 800 BC, was reportedly constructed of burnt bricks covered with bitumen as a waterproofing agent. Bitumen was used by ancient Egyptians to embalm to embalm mummies. The Persian word for asphalt is moum, which is related to the English word mummy. The Egyptians' primary source of bitumen was the Dead Sea, which the Romans knew as Palus Asphaltis, which is asphalt lake. In the United States, the first use of bitumen in the New World was by indigenous people. On the west coast, as early as the 30th century, the Tongva, Louisiano, and Chumash peoples collected the naturally occurring bitumen that seeped to the surface above underlying petroleum deposits. All three groups used the substance as an adhesive. It is found on many different artifacts of tools and ceremonial items. For example, it was used on rattles to adhere guards or turtle shell to rattle handle. It was also used in decoration. Small round shell beads were often set in asphatum to provide decoration. It was used as a sealant on baskets to make them watertight for carrying water, possibly poisoning those who drank the water. Asphalt was used also to seal the planks on ocean-going canoes. Asphalt was first used to pave streets in the 1870s. At first, naturally occurring bituminous rock was used, such as at Ritchie Mines in McFarland in Ritchie County, West Virginia, from 1850 to 1873. In 1876, asphalt-based paving was used to pave Pennsy- Pennsylvania Avenue in Washington, D.C., in time for the celebration of the National Centennial in the horse-drawn era. U.S. streets were mostly unpaved and covered with dirt or gravel, especially where mud or trenching often made street difficult to pass. Pavement were sometimes made of diverse materials, including wooden planks, cobbler stones, or other stone block or brick. The fifth one is modern use. Global use. The vast majority of refined alpha is used in construction, primarily as a constituent of products used in paving and roofing applications. According to the requirements of the end use, asphalt is produced to specification. This is archived either by refining or blending. It is estimated that the current world use of asphalt is approximately 102 million tons per year. Approximately 85% of all the asphalt produced is used as a binder in asphalt concrete for roads. It is also used in other paved areas such as airports, runways, car parks, and footways. Typically, the production of asphalt concrete involves mixing fine and coarse aggregates such as sand, gravel, and crushed rock with asphalt, which acts as the binding agent. Other materials such as recycled polymers, like example is rubber tires, may be added to the asphalt to modify its properties according to the application for which the asphalt is ultimately intended. A further 10% of global asphalt production is used in roofing applications, where its waterproofing qualities are invaluable. The remaining 5% of asphalt is used mainly for sealing and insulation, proposed in a variety of building materials such as pipe, coating, carpet tile backing, and paint. Asphalt is applied in construction and maintenance of many structures, systems, and components such as the following: highways, airports, runways, footways and pedestrian ways, car parks, racetracks, tennis courts, roofing, dam proofing, dams, reservoir and pool linings, soundproofing and pipe coatings. Rolled asphalt concrete. The largest use of asphalt is for making asphalt concrete for road surface. This accounts for approximately 85% of the asphalt consumed in the United States. There are about 4,000 asphalt concrete mixing plants in the US and a similar number in Europe. Asphalt concrete pavement mixes are typically composed of 5% asphalt, cement, and 95% aggregates like stone, sand, and gravel. Due to its highly viscous nature, asphalt cement must be heated so it can be mixed with the aggregates at the asphalt mixing facility. The temperature required varies depending upon the characteristic of the asphalt and the aggregates, but warm mixed asphalt technologies allow produced producers to reduce the temperature required. The weight of asphalt and asphalt pavement depends upon the aggregate type, the asphalt, and the air void contained. An average example in the United States is about 112 pounds per square yard per inch of pavement thickness. When maintenance is performed on asphalt pavements, such as milling to remove a worn or damaged surface. The removed material can be returned to a facility for processing into a new pavement mixtures. The asphalt in the removed material can be reactivated and put it back to use in new pavement mixes. Mastic asphalt. Mastic asphalt is a type of asphalt that differs from dense graded asphalt concrete, in that it has a high asphalt binder content, usually around 7 to 10% of the whole aggregate mix, as opposed to rolled asphalt concrete, which has only around 5% asphalt. This thermoplastic substance is widely used in the building industry for waterproofing flat roofs and tanking the ground. Mastic asphalt is heated to a temperature of 210 degrees and is spread in layers to form an impervious barrier about 20 millimeters thick. Number 6 is production. About 40 million tons were produced in 1984. It is obtained as the heavy, difficult to distill fraction material with a boiling point greater than around 500 degrees is considered asphalt. Vacuum distillation separates it from the other components in crude oil such as naphtha, gasoline, and diesel. The resulting material is typically further treated to extract small but valuable amounts of lubricant and to adjust the properties of the material to suit application. In a de-asphalting unit, the crude asphalt is treated with either propane or butane in a supercritical phase to extract the lighter molecules, which are then separated. Further processing is possible by blowing the product, namely reacting it with oxygen. This step makes the product harder and more viscous. Asphalt is typically stored and transported at temperatures around 150 degrees. Sometimes diesel oil or kerosene are mixed in before shipping to retain liquidity. Upon delivery, these lighter materials are separated out of the mixture. This mixture is often called bitumen feedstock or BFS. oil sand, naturally occurring crude bitumen impre- impregnated in sedimentary rock is the prime feedstock for petroleum production from oil sands. Currently under development in Alberta, Canada. Canada has most the world's supply of natural bitumen, covering 140,000 square kilometers, an area larger than England, giving it the second largest proven oil reserves in the world. The Athabasca oil sands are the largest bitumen deposits in Canada and the only one accessible to surface mining, although recent technological breakthrough have resulted in deeper deposits becoming producible uh, by in situ methods, alternatives and bioasphalts. Although uncompetitive economically, asphalt can be made from non-petroleum based renewable resources such as sugar, molasses and rice, corn, potato starches. Asphalt can also be made from waste material by frictional distillation of used motor oil, which is sometimes otherwise disposed of by burning or dumping into landfills. Use of motor oils may be cause of premature cracking in colder climates, resulting in roads that need to be repaved more frequently. Non-petroleum based asphalt binder can be made colored light-colored roads absorb less heat from solar radiation, reducing their contribution to the urban heat island effects. Parking lots that use asphalt alternatives are called green parking lots. Albania deposits. Selenizza is naturally occurring solid hydrocarbon bitumen found in native deposits in Selenized in Albania, the only European asphalt mine still in use. The bitumen is found in the form of veins, filling cracks in more or less horizontal direction. The bitumen contains various from 83% to 92% soluble in carbon disulfide, with a penetration value near to zero and softening point, ring and ball, around 120 degree. The insoluble matter, consisting mainly of silica ore, ranges from 8% to 70%, 17%. Sorry. Albanian bitumen extraction has a long history and was practiced in an organized way by the Romans. After the centuries of silence, the first mentions of Albanian bitumen appeared only in 1868 when the Frenchman Coquelin published the first logically, geological description of the deposits of Albanian bitumen. In 1875, the exploitation rights were granted to the Ottoman government, and in 1912 they were transferred to the Italian company named as Simsa. Since 1945, the mine was exploited by the Albanian government, and from 2001 to date, the management passed to a French company, which organized the mining process for the manufacture and natural bitumen on an industrial scale. Still in Albanian deposit today, the mine is predominantly exploited in an open pit quarry, but several of the many underground mines, deep and extending over several 1 kilometer, still remain viable. Seleniza is produced primarily in granular form after melting the bitumen pieces selected in the mine. Seleniza is mainly used as an additive in the road construction sector. Number 7 is recycling. Asphalt is commonly recycled material in the construction industry. The two most common recycled materials that contain asphalt are reclaimed asphalt pavement, which is RAP, and reclaimed asphalt shingles, RAS. RAP is recycled at a greater rate than any other material in the United States and typically contains approximately 5 to 6% asphalt binder. Asphalt shingles typically contain 20 to 40% asphalt binder. Asphalt naturally becomes stiffer over time due to oxidation, evaporation, exudation, and physical hardening. For this reason, recycled asphalt is typically combined with virgin asphalt, softening agent, and or rejuvenating additives to restore its physical and chemical properties. For information on the processing and performance of RAP and RAC, see asphalt concrete. For information on the different types of RAC and associated health and safety concern, see asphalt shingles. And the last for information on in-place recycling methods used to restore pavement on and roadways, see road surface. Number 8 is economics. Although asphalt typically makes up only 4 to 5% by weight of the pavement mixture, as the pavement's binder, it is also the most expensive part of the cost of the road paving materials. During asphalt's early use in modern paving, oil refiners give it away. However, asphalt is a highly traded commodity today. Its prices increased substantially in the early 20th century. Australian government report states in 2022 asphalt sold for approximately $160 per ton. By the end of 2006, the cost had doubled to approximately $320 per ton, and then it almost doubled again in 2012 to approximately $610 per ton. The report indicates that an average 1 mile long 4-lane highway would include 300 tons of asphalt, which in 2002 would have cost around 48 $48,000. By 2006, this would have increased to 96,000 and by 2012 to $183,000, an increase of about $135,000 for every mile of highway in just 10 years. The last one is number 9, health and safety. People can be exposed to asphalt in the workplace by breathing in fumes or skin absorption. The National Institute of Occupational Safety and Health and IOSH has set a recommended exposure limit of 5 milligram per meter cube over a 15-minute period. Asphalt is basically an inert material that must be heated or diluted to a point where it becomes workable for the production of material for paving, roofing, and other applications. In examining the potential health hazard associated with asphalt, the International Agency for Research on Cancer IARS sorry, IARC determined that it is at the application parameters predominantly temperature that affects occupational exposure and the potential bioavailable carcinogenic hazard risk of the asphalt emissions. In particular, temperatures greater than 199 degree were shown to produce a greater exposure risk than when asphalt was heated to lower temperatures, such as those typically used in asphalt pavement mix production and replacement. Hi again, my name is Manazi. Now I'm going to presenting about my journal that study about of bitumen characteristic with the use of a waste plastic. So the abstract in the country in their country plenteously of industrial surplus is produced by industrial activities due to industries, refines, and coal fields. In further by adding industrial waste products, municipal solid surplus of garbage comprising non-biodegradable ingredient to is to created inside the municipal limits. This is a main basis of ecological pollution effects and also suitable disposal in major difficulty in order to save the environment. The usage of surplus plastic in the formation of the road was main concern taken in this route. Usage of appropriate road waste solid in the building of roads not only make available uh, sustain, substantial equivalent on road material cost, but it also helps in to solve the situation of this kind of waste material in India is much like in road construction of national highways, state highways and village roads. Further, the use of plastic flask, vessels, and filling cans is accumulative every day, and its disposal becomes as main use issues. Since these products are now not biodegradable, possible to stay in the environment for several decades, making environmental issues health threats. The paper advanced to debate and in aspect as to by what method the plastic waste can be controlled and can be used effectively in the information in the in the formation of roads, thus modifying the environmental issues and saving the budgets of building of roads inside the country. So, for introduction, plastics are non-biodegradable synthetic polymer formed by a chain hydrocarbon with addition of additives shaped into finished. These plastic polymers are smashed in existence of proper catalyst into monomers such as ethylene, propylene, vinyl, styrene, and benzene. These monomers further chemically polymerized into various groups of plastic. Removal of plastic surplus is a major concern in India. None methods have been advanced to decrease this contrary effects on the environment. Recently worldwide accepted methodology which can be effectively used for the plastic dumping incineration. However, the incinerators design seek discharge particularly toxic composites, which is a chlorinated dioxin and furands. Consequently, increasing many environmental concerns. Nowadays, various safe disposal technologies of plastic waste have been investigated. So the aim and objective, the paperwork titled as a use of plastic waste in bitumen and aggregate of 4 root aims at analyzing effects of utilization of plastic waste in aggregates and bitumen of 4 root. The present study was initiated to study properties of normal and modified properties of aggregates and bitumen. The major objective of current work are: number one is to perform various tests on aggregated and bitumen aggregate. Number two is to analyze and discuss results obtained from tests. Number three is to find suitability for using plastic modified aggregate and bitumen. Number four is variation of a result of aggregate impact test by using different percentage of plastic. Number five is variation of results of Los Angeles aberration test by using different percent of age of. And then number six is variation of result of ductility test WRT 0% plastic. And the last one is variation of results of penetration test WRT 0% plastic. So methodology and data collection. So the first one is methodology. Number one is literature review of a related study was done. Material was produced from lab. Number three is tests were performed on material in transportation lab. Number four is analysis of results was done. Number five is result and discussion was prepared. So test performed on aggregate. So number one is aggregate impact test. Los Angeles aberration test performed on bitumen. Number one is penetration test, and number two is ductility test. So for the conclusion and recommendation, the waste plastic in construction of roads carries out unchanged performs as in it show improved binding of bitumen with plastic. The frequency of voids is also minimized by increased bonds and area of contact between polymers of plastics and bitumen. This is the long run helps in reducing the humidity absorption and oxidation of bitumen by trapped air. Hence, the roads can be weighty traffic, thereby making it much durable. However, the involvement of rubber aggregate, on the other hand, even though mixing in bituminous mix declines the amount of stone aggregate by volume, forms it further flexible, and also raises the flexural strength in the topmost layer of the highway. The surplus tires present used as well-sized and shaped aggregate in the reduced the pollution occurred due to excess tires and also condensed the use of a predictable aggregate present in exhaustible quantity. So A is discharging, discharging of discharged plastics will not extended remain problem. Number two is by using of plastic aggregates eliminates the problem of thermal cracking and permanent deformation. Number three is conventional stone aggregate can remain protected to defined quantity. Number four is some problems like thermal cracking and long-lasting deformation are minimizing in warm region. Number five is, as we know, that rubber has ability of absorbing the sound, further helps it in minimize the noise pollution of traffic roads. Number six is waste rubber tires thus can be put to us, and it ultimately improves the quality and performance of road. The last one is optimum content of excess rubber tires, effectively used in is in between the range of 5 to 10%. So that's all for me. Thank you and assalamu alaikum.